Okay, thank you. That was an awesome talk. So we're going to continue now with the program, and as I introduced myself earlier, I won't reintroduce myself, but I will say that if anybody wants to tweet throughout the day, use the hashtag Microservices Days, please. And so what I'm going to be focusing on in this talk is really a core essence of a big part of what we do around microservices, which is the decomposition of a monolith, right? And looking at the issues surrounding decomposition as a whole. So I'll start with why microservices, and I like to shorten microservices with the mu symbol because it's a lot easier, and I've gotten really good at finding the keys that you got to press to get the symbol automatically off the Mac. So I'm not sitting there searching for symbol every single time, but it certainly removes a lot of characters. If only I could get Twitter to represent that symbol, that'd be great. But so what is this thing, right, that we talk about, this monolith? To me, I've been in this game so long, the monolith to me is the COBOL app running on the mainframe still. And I have people now, starting to really express this microservices universe in terms of the monolith. And I look at the monolith and I'm like, shoot, that was the stuff that we abstracted out and created interfaces and APIs and we called modular just 10 years ago. And now it's the monolith. So it took me a while to reconcile what is the monolith? Why are we calling this a monolith? It's supposed to be modular. But what's happened, and rightfully so, is that as this software has been maintained over a period of time, there's been a recognition that the way that these pieces have come together, the way that they have been oriented and structured in the environment for deployment are so tightly integrated that it's hard to make a simple change and just deploy that change. So as we've been moving, now this wasn't recognized 5 years ago because continuous integration was, while popular, continuous delivery is a very new concept, and everybody's rush to do continuous integration, continuous delivery, continuous deployment is like 2 years, 3 years old at best, with regard to the mad dash to go do this. And as organizations have taken on this initiative to go do this really great thing called the CI/CD, all of a sudden now they realize, oh man, we got a bunch of technical debt and garbage that's limiting us from doing this. So they called it the monolith, right? So the idea here is now, all right, if we really want to do microservices, we have to first break this thing down. And in and of itself is a huge body of work and incurs a lot of new decisions that need to be made. And frankly, I don't believe that the organization is well endowed to make those decisions. To Michael's talk prior, who's got the map to what all these applications are and how they're built, right? That should have been the EA, but they're out on the ice now. We'll get an arrow shot at them. Is that correct, Michael?
That's right.
So that's a sad thing. But so Michael, you made me feel bad. I actually had this on. He's like, oh man, he's put the kibosh on Conway's Law, which I actually, it took me a long time to get this one too. I love the way that people just throw stuff out. Oh, and we both know John Willis very well, but John really brought this back into the fold, this Conway's Law. I'm like, oh, what is he talking about? John, you live in Atlanta. Marijuana's not legal there. But when you finally start to look at this stuff, you begin to understand a little better what the implications are. And one of the best ways I've seen Conway's Law really come into existence or represented was that the way we built those modular applications in the past really lent themselves towards a lot of implicit knowledge being shared across the teams. So when you have that implicit knowledge, you tend to use it. And this goes all the way back to the Windows development, and back in the mid-90s, right? People who knew about non-documented APIs in Windows took advantage of them. Now, lo and behold, Microsoft said don't do that because there's no guarantee it's going to be in the next version, and people didn't listen, and all of a sudden their software broke when the new version of Windows came out, right? But that inherent knowledge, that creates these problems. And so when you're sharing that knowledge and development, you have your front-end developers who implicitly know that there's a field in the database that we can use to do this. Well, now you're binding yourself very tightly to this stuff, right? So the new motif, the new methodology for delivering applications is to use a cell architecture, right? Where all your teams are cross-functional. They have what they need embedded in the team, but the teams operate independently. And a really good example of where this has been hugely successful, of course, is Amazon, where Jeff Bezos years ago said everybody in every department from here on out needs to communicate through an interface, and they have to publish that interface publicly. And he made it a mandate. And once he did that, I mean, this was back in the days when Amazon was just a book reseller. And all of a sudden, why can Amazon do what Amazon does today at the speed it does? It's because essentially their organization is a set of microservices. So, fractal in nature, so to speak, in delivery, but it works. And so, so these are key concepts that we need to keep in mind as we start to analyze whether something needs to be decomposed or not. But that is the question, right? To decompose or not to decompose. And it seems like we have in IT, especially enterprise IT, very much a group of extremists. It's all or nothing. It's like, oh, this is the new way to do something. Everybody, this is the only way we're going to do it from now on. And it's not just engineers. I mean, I work with a customer where the senior vice president said, everything from here on out is going to be microservices. And you sit there going, yeah, I'm waiting for that disaster to hit. But, these mandates, we will do it only this way, don't take into account that there are situations in which decomposition is not the right thing to do. And there is something to be said for the speed and cadence of how the application works itself when it is tightly bound together, when it has that inherent knowledge. Take something as simple as a join across databases, right? Where the application does what the application does because all the modules are feeding into a centralized repository, and now I can aggregate that information using the capabilities of the database to report out. So, just because now the new hot thing is that we should break everything up into microservices and not follow it or allow the anti-pattern where I directly go to the database itself, but I go through a microservice. So now I have to create a whole new layer to do what I got for free before. And what value am I getting from that? And that really gets to the gist of why are you decomposing, right? So you have to answer some questions, and those questions have to, are along the lines of one, is there a financial benefit, or in the lean method, am I moving towards profitability by breaking this monolith up into microservices? Am I gaining something out of it in one of four quadrants? The first is speed. So number one thing we want to get out of microservices is speed to delivery. Being able to innovate, being able to move stuff out to the market quicker. The second is quality. Second is cost, right? Am I reducing costs of maintenance? Am I reducing the cost to deliver and develop something? Third is quality. Am I increasing my quality because I can, the basic nature of control how many variables are changing at once. So I have a very small, if everything is now in these small, very focused, do one thing well kind of entities, do I get the increase in quality that I'm expecting by not having to change a lot of things? If I go back to that bundle and monolith thing, I change one thing in there, Lord knows, especially with some of the spaghetti code that's been written over the years, what else gets hit, right? So the smallest change requires me to regression test the entire application, whereas now I'm able to change one thing and I'm able to introduce it into the ecosystem and very quickly realize and fail fast whether I need to roll that back out or it's going to work. So it's not like I have to take a maintenance window, take the whole application down, put out the new application, and then bring it back up, and then find out, oh, there's bugs, and people are trying to access it, and the phone calls start, and hell breaks loose, and everybody loses their job, you start all over again on Monday. So, you know, those are I'm very pragmatic. It's why I do what I do. It's the way I write. You know, if anybody's interested, I'll share my diatribe I did to Michael earlier this morning on why containers really aren't the best thing in the world. The fanboys hate me because I always, you know, poo-poo on their parade. But the truth of the matter is, decomposition's not always the best thing in the world. There really has to be a financial or economic value to the organization to undertake this, because it's a lot of work and it's very expensive. But if you are going to do it, right, so there have been a number of different approaches that have been talked about, and you can read about them all over the web. But, you know, what I have found as a decomposition strategy that works best is starting with bounded context. So I'm going to go into each of these in depth, so, you know, and then trace your dependencies to the bottom. That's a really interesting one that I haven't seen discussed too much, right? Because inherently when you develop software, you build, it's natural, and you want to build dependencies in code. It's, you know, really, how you functionally develop out a application is you start with a piece of code, it gets past a certain number of lines, you break that out into a function, you call that function, and you keep doing that iteratively until you have your application. So naturally, when you start to now have to decompose this thing, you have to be able to trace those through. There's another big issue with decomposition that I have found is some of the messaging infrastructure and approaches that have been taken throughout the past few years are now coming back to bite us in as the worst technical debt disaster that we could have ever thought of. It makes, on the order of, real world situations, it's equivalent to the college debt problem. Then we have to, deal with how do I get to the data? And then, ultimately, it's about being able to deploy and test on a very frequent basis, because every small change could either be work or introduce a huge problem that now needs to be reevaluated. So you're in a very tight cyclical loop, trying to make sure that every step of the way that through decomposition that you haven't broken anything. So let's start with contextual boundaries, and just make sure everybody kind of gets this. I came up with this small scenario for a microservices introduction I did, but it's really good at setting the mindset, right? So here I have the example of a company that has multiple business units, right? They have a network, they have the enterprise, they have an entertainment, right? So the idea being that each one of these business units looks at customer in a very different way. But likewise, there's actually enterprise functions like customer management that need to occur, and you don't want them to occur 3 different ways. The outcome to you as a customer would be, I get, Verizon phone and Verizon Fios, and I get 2 separate bills. It's like, of course they rectify that and they normalize that so you only get 1 bill at the front end. But is it really internally, are you represented as one customer? Or are you represented customer 20 different ways, and they pay a bunch of people to go and aggregate all this information and make it 1 bill, what looks like 1 bill to you? That's an expensive proposition that it doesn't naturally come out of the system. And the reason why it doesn't come out of the system that way is because you're not represented that way as a customer. So that's what we're trying to achieve, right? So here, if I take this scenario a little bit further, right? I have a subscriber to Verizon service. I have and they are the provider, and in between is this payment processor, right? So the first thing is that I'm going to, on the provider side, I'm going to prepare a bill, and then I'm going to want to send the bill to the customer, to the subscriber. Oops, sorry. All right, so here I have billing represented. Now, talk about the monolith. What is the monolith in terms of the business. The monolith is that billing is an application that is all-consuming. I mean, it is the heart of a service provider. And so what they do is they create this billing application that does everything you could ever want to do in billing. But it doesn't really understand the essence of what the service is, right? So, you know, if I'm starting to think decomposition, the first thing I want to do is I want to carve up that billing system. I want to make the billing system a set of microservices, because that's where I'm going to get huge advantages, because now I can start to aggregate or compose new business logic using that separate capabilities, right? So I'm going to break billing into prepare and billing into deliver. And I can now represent those parts of billing independently relative to the context of how it's going to be used in the business. Likewise, when the customer pays, right, they receive the bill, and then they're going to pay it, and so they need to process the payment. All right, so this is where it starts to get interesting now. So there's a couple of different ways that I could process a payment. The subscriber sends it directly to the provider, form of a check to an address or maybe credit card over the phone, and the provider's then going to take that information and they're going to go to the payment processor, which is usually a bank, and they're going to clear that transaction. Likewise, another way they could go is they could send the subscriber directly to the payment processor, and then the payment processor is going to pass that information off into the provider itself. So here I want to be very agile, right? But the key thing that I want to do here is I can support today the payment receiving capability of my monolith. I can receive credit cards, I can receive checks, I can receive cash, coin rolls. You can go into an outlet and drop off your money, whatever. I have all these great methods, but let's say tomorrow I wanted to accept Bitcoin. Okay, so typically what's going to happen here is if I want to accept a new type of payment, I'm going to have to go change my payment receiving application logic and redeploy that, which is very time-consuming, expensive, and now I have to test every single method to make sure that I'm updating my accounts properly. Whereas if we break this apart into a set of microservices and deploy the Bitcoin payment processor, I can now just take the, I guess it's an email address of the individual and the network on which they are, and I can issue a transaction against that, and then just get notification to update their account that they're paid. So I gain flexibility by not having everything so tied together. But the key part of the valid context is that as I start to carve off functionality, I'm binding it to a specific business entity, a component of the way that the business is operating. Now, this is really difficult, and you're not going to get it right the first time, and you're not going to get it right the second time. It's just the nature of the beast, right? The third version is typically where you start to see maturity. This is what law is this? What should we name this? Microsoft's law? Microsoft's law. We get it right on the third time. So, and this is where software development in enterprises really gets tricky, because when you have something of this magnitude that impacts the business so detrimentally, right? There's a business organization that's funding these changes. There's some amount of money that's being pulled, whether it's from sales or from operations, to make this, to pay for the software development behind this code. And so you say, hey, it's going to cost us initially, $2 million to tear apart the billing and payment system and put it back together as a set of microservices. Okay, great. And then, 6 months into it, you say, you know what? That version 1 that we did of those services, they're not so good. So we're going to throw them away, and we're going to do version 2. And that's where the business really isn't ready to receive this whole new microservices universe, because they look at it and go, you threw it away? You're going to throw away code, and you need more money? You failed. Well, no, we didn't fail. We're learning, and businesses don't learn well. They inherently are not heuristic entities. They particularly like to build onto and continue to maintain their assets and their investments. So this is seen as an investment, and so right from the get-go, as you're going through this process, you really need to bring the business along. You need to help them understand the fundamental shift in thinking that goes along with this decomposition. So it's like, look, it's a really simple argument, one that they may or may not buy into, but I can continue on with this set of code in the way it's written, and every time you want to change, I'll tell you to come back in 6 to 9 months, and I'll have it ready for you. If you can survive as a business, if we can survive as a business with me doing it this way, then let's keep going down this path. However, if you feel like these companies like Amazon and Microsoft are quickly going to be competitors in your space, and you need to address that, and we can't do it with this lump of code here and the way it's formed, then you got to take the ride with me. And so you need to bring them along that journey. They don't understand it. The next big thing as you go through these gyrations is that, and I guess you don't have to, but there's a benefit to shifting the thinking from objects to resources. Now, I hope most code today is at least got some level of object-oriented programming design in it, because that's more maintainable than flat code and just functional coding, right? So now the trick is that objects themselves are inherently static by definition. They're designed into the code. They represent data structures within the application. But now there's this shift to this thing called the resource, where instead of thinking of a light switch as a subclass of switch, which has certain features, and we're going to send messages to that object to turn on or turn off, right? So, on the left we show turn off light. That's typically a method that you would find on an object, and the object's encapsulating how it manages the light. You don't know how it actually does it. You just have methods for turning on a light, turning off a light. Now, we start to look at them as resources. Resources are just addressable entities, assets. And the way I change or turn a light on or off is by sending state changes to that resource. Okay, so now all of a sudden, instead of having a specific on-off, I'm going to inherently change the state of that resource by sending in a message that the state is off. And assumedly, by sending that message to that address, I'm going to get the activity or outcome that I expect. This is a big change in thinking, because one, it's very dynamic, it provides us the opportunity to really be very fluid in our outputs, where as the business changes, you can very quickly keep up with the changes required for the business by not having these fixed definitions. On the other hand, there's something to be said for strongly typed languages, which is why people hate JavaScript, right? It's like, it's not strongly typed, so you very easily, it's not compiled, so you don't, there's things that are simple errors that would have gotten caught by a strongly typed language in a compiler, somehow make it into production, and you don't find out until you're actually running this thing for a while that you have this bug in JavaScript. So there's strength, but this seems to be, when you design the microservice, seems to be the approach, the REST-based API approach, seems to be the popular approach that everybody's moving to. So you have to, I've seen companies, I'm working with one actually, where they're trying to take their APIs that they built, which were very much extensions of the object paradigm, right? They turn on switch, turn off switch, and through SOAP web service interfaces, and go to REST. And what they're trying to do is just automatically map the SOAP stuff to the REST stuff. And I'm like, no, you can't just do that. The paradigms are different. You actually have to create a new interface for the resource. It's a different animal. And it doesn't work well when if all you're doing is going from SOAP to REST, all you're doing is you're not really going to REST. What you're doing is you're changing the marshalling to JSON from XML. So call it what it is. You're just changing the marshalling. You're not actually changing the API or moving to REST. But they'll say, hey, we're doing REST. No, you're not doing REST. So that's another, in order to move that ball forward, you have to make the decision, what do we really want to do with these microservices? Are we okay following the old, no, I shouldn't call it old, following the more traditional remote procedure call interface, or do I want to move towards the representation of things as resources? And then, okay, so we talk about tracing these dependencies, right? So, so there's entanglements around the persistence of data, right? And then we talk a little bit about that, where people who have developed different parts of the code all make assumptions that this particular piece of data is going to be in the database, right? So this is normal and expected when building what we call the monolith. However, when we start to decouple these pieces, we find that we have these hooks, right? And it reminds me a lot of, like science fiction, where you get these worms that like hook into your skin and you like can't get them out and you have to surgically remove them. Well, that's what you're going to be doing in the code. You're going to be surgically removing these hooks that have been placed in the application. They have code dependencies, right? Shared data structures. What am I doing with this shared data structure? In C++ or Java, I have a class file that represents this code that I'm going to use across all my application modules, and it's going to represent, this will give me a consistent representation of this data throughout the system, and I can, use my Spring capability and inject, have proper injection into it and all this other stuff. And now I'm going to put it into its own microservice. Do I carry that with me? Do I take the representation of that shared representation as I start to rip stuff apart? And then what happens is when I have 42 or 50 microservices out of one block of code, all sharing the same data structure, and I want to start changing that data structure. Now it's represented in 50 different projects in my Git, and I have to start managing, because remember, I don't have the shared services team. Everybody's now managing this piece of code for themselves in their own functional team. So, this is a complex decision to decide how you're going to consistently represent data throughout, which is why the resource moniker actually works well, because it's fluid and dynamic, and you don't break something if you decide not to use an attribute. Yeah, question at the end. Good. Yeah. And then finally, direct connections with services, databases, messaging, logging, all the ilities and the non-functional components to your application. How do you manage them, right? If you're logging, if you had a shared logging service, right? If you broke it out as a microservice, that would work well, and certainly that's something that is common with architecture today, is that many people are going to these as shared services. But if they were not, then that can be extremely problematic as you're tracing it down. And of course, you have to then untangle the data, right? And one of the tenets of microservice design is that each microservice should manage its own persistence of its own state for itself. And that gets confusing, is that I can't put it all in the same database anymore. Am I caching data from a single source, or the gold source, out into the edge where my microservice lives, as indicated by these microservices on the right? There's a lot of confusion around this stuff right now. People are unsure as to what that tenet actually means, that have distributed data and data management as part of microservices. So, and that's, believe it or not, one of the things like this, complex problems like this, is why I worked with DevOps.com to start Microservices Journal, because there really wasn't a place to discuss this and go and debate these issues anymore, right? We years ago, we used to have things like the OMG and the Open Group, and they really aren't as actively involved in the community. They don't have a community anymore. they're still stuck in 1990s, pay me a big fee to join my group and I'll let you come play. So, like, you know, there's a bunch of old guys, you know, in their shorts and like senior citizen home now in the OMG meetings. So, you know, we needed a community to discuss these things. And then finally, the big one, untangling the MOM, the message-oriented middleware, right? So somewhere along the lines between 1999 and 2015, people got the great idea when XML emerged that, hey, we should define everything in XML. So your application looks like nothing more than load template, call mapping. And so, you know, as you start to reverse engineer your code, which you need to do as part of this process, you don't actually see the business logic. All you see is load template, map code, translate. Okay, well, that's great. I guess this piece of code goes with me. Where's all the business logic? Where's all the mapping logic? Oh, they're in XML files. Does anybody here know of a tool that reverse engineers the camel and the XPDL stuff? Because I haven't found one yet, right? So when you're actually, and I've talked to like the likes of CAST Software, which is like the reverse engineering engine, like Accenture, every major outsourcing user, anyone who does managed services around applications uses this tool to reverse engineer, right? And they're trying to get me to buy in, and I'm like, okay, so can you reverse engineer Camel and XPDL? And they're like, no. So I'm like, that's where everything's stored now, right? The entire application is really nothing more than, you know, a set of mapping exercises, because that's what SOA was, right? SOA was really this enterprise service bus, unified messaging. We're going to do everything on the bus, and now microservices, where dumb buses, smart endpoints. Wow. Well, so all the stuff that's in the bus, I now need to rip out and put at the endpoints. I don't know what's on the bus. No, I have some diagrams that people auto-generate XML from. So this is really a difficult problem. I actually, you know of a company that's struggling with this, and their answer is basically to take a microservice and wrap. You take the API that just calls the mapping, and that's a microservice. And I'm like, why did you bother calling this a microservice? You didn't change anything about the way your application is operating. And frankly, you have the same size stuff that you have to deploy and test regardless of whether you call it a microservice or you call it a monolith. So this is really interesting. The other pieces of this is, you know, the configuration stuff, the Spring stuff, the attributes injected at runtime. When you start, it's great when you have a config file for your monolith that's like this big or maybe this big, and it has all the things, and you start carving pieces out. What happens to all those attributes and those configurations, and and which ones are going to move over to the microservice to, you know, on boot to be injected into the application, and which ones are staying? And then you have things like aspect-oriented programming. Anyone here do aspect-oriented programming? That was a big thing. Yeah, there we go. As an AOP here. So, you know, now you have these crosscuts that are actually, you know, aggregating other components to create this like new component, and you're trying to now, and one of those components is going to become a microservice. So, you know, what happens with those? So you have to, there's a lot of unwinding. So, you know, the funny thing about microservices that I see is that, think about how we talk about them. They're small, they do one thing well. Oh, these are easy. This is like, you know, this is beautiful. I can understand this. It's small. It does one thing well. This is, you know, it's the most simple thing in the world. We should all build all the software this way. Okay, great. But all your code is stuck in this like monstrous, hideous spaghetti code thing, and you're going to now carve it up and make them these nice little pretty things. That complexity. And I won't even talk about the complexities of really the simple things to run. You saw the network picture that Michael had up there for Netflix, which was like, you know, and when you start to tie all the point-to-point connections together, you end up filling in the whole ball, right? So it really, you know, back to, do I decompose or don't I decompose? And the sad thing is, you know, it's technical debt. Technical debt officially is a decision you made years ago knowing full well that you were starting to accrue interest from the minute you made that decision, but you did it for efficiencies, and it's coming back to bite you in the ass. It's a margin call, and they want their money. So eat it. I don't know, throw it out, restart, I don't care what you do, but the technical debt, the banker's at the door saying, I want my money, right? So to summarize, and then I'll take a question. Decomposition may not always be the most appropriate thing for the business. Drivers for microservices, speed, cost, quality, and one I didn't mention that I often throw in there, user experience, okay? The fact that you have these bundled contexts might require significant rework when you start to trace the dependencies down. You do need a plan if you are going to move from the objects/functions to assets or resources, how to get there, what is going to be the ground rules, how are you going to govern this, and then finally, the one I haven't spoke about yet, the strangler pattern, right? There's a lot of talk. When you get into microservices, you got to mention the strangler pattern. If you don't mention the strangler pattern, you go in an interview, you don't know what the strangler pattern is, you're not getting that job. And I'm like, when I first started hearing it, I'm like, I don't get it. Isn't this just abstraction? Isn't this the stuff that we did anyway when you create, service virtualization? We did this in the, mid-2000s, right? You're just creating an abstraction. So what's the big deal? The strangler pattern. But so take it for what it's worth, right? I mean, abstraction is a big part of what we're going to be doing here as we carve off these pieces into microservices, right? The idea being that we created this new abstract entity. It's what you use to actually execute that part of the business logic. You don't go back to the original. Hence, like a tree limb, it'll actually finally die off one day. But it still exists in the code, which means that somebody will call it somewhere, and 20 years from now, you'll have to have the microservice and that module, and you'll be maintaining both of them. So that's life. You had a question, sir. Hello? You had a question?
That was earlier.
Oh.
I was just,
okay.
What you seem to describe, I've heard it termed as a distributed monolith, when people don't do the actual decomposition right.
Oh.
They don't break the monolith into lots of pieces, but they all still...
I didn't know it had a name. Distributed monolith.
Right, so now you have the network...
How about mess? Can we call it a mess?
But I just see that happening a lot.
Yes. Yeah, well, this stuff is complex, right? And
the hard work is that decomposition.
The hard work is the decomposition. And I love, when you actually bring this stuff up, I had a client who tells me, it's a work in progress. We're not going to eat the elephant in one bite. It's like, I get it, okay, but still, how about taking at least not nibbles, but bites?
What about your thoughts? A lot of people say actually starting with a monolith is the right way.
Yeah, that's a good point.
And then understanding how the dependencies work. Of course, hopefully build a monolith that has good abstractions.
Right. So the point being is, the right way. A lot of people say that the right way to do microservices is to start with the monolith versus greenfield. And there's a lot of truth to that, right? Because what are your bound? You know how hard it is to come up with a set of bounded contexts from nothing,
yeah.
Right? You could do it, right? You could start with enterprise architecture and have them map the business, right? And say, okay, we have these functions in the business, so we're going to greenfield and call our, we're going to break down our microservices based on that. I actually know of a group that did that based on standards. Actually, there's two of them based on standards. The telecommunications industry is doing a microservices initiative based on their TDE standards, telecommunications standards, and then the banking industry has one called BIAN that's also become a set of microservices. So I guess if you in an industry, if you have an agreement on how to break the business up, a domain, a well-defined domain, but to just come into your business, you functionally organized and against the command and control hierarchy and try to figure out what's the best way to carve that business up as a set of bounded contexts. Chances are it's going to be, you'll spend 2 years trying to figure out what the domains are and get no work done.
But you got dissonance if the organization structure doesn't manage those boundaries, right?
That's right. You don't know. But if you have a piece of code that is doing something, then in there, oh look, we have billing. Let's represent billing. So it's easier to see how different things occurred. Anyway, one more time. I got 4 more minutes. So any other questions? I thought I was over at 11. Look, I really once again want to tell you all I appreciate you coming out. when you start something new and you never know what to expect, you know, my worst fears with 3 people were going to be in the room. So hopefully you're enjoying the content so far, and thank you again for coming.